Earth is the third planet from the Sun and the only astronomical object known to harbor life. According to radiometric dating estimation and other evidence, Earth formed over 4.5 billion years ago. Earth's gravity interacts with other objects in space, especially the Sun and the Moon, which is Earth's only natural satellite. Earth orbits around the Sun in 365.256 solar days, a period known as an Earth sidereal year. During this time, Earth rotates about its axis 366.256 times, that is, a sidereal year has 366.256 sidereal days. Earth's axis of rotation is tilted with respect to its orbital plane, producing seasons on Earth. The gravitational interaction between Earth and the Moon causes tides, stabilizes Earth's orientation on its axis, and gradually slows its rotation. Earth is the densest planet in the solar system and the largest and most massive of the four rocky planets. Earth's outer layer, lithosphere, is divided into several rigid tectonic plates that migrate across the surface over many millions of years. About 29% of Earth's surface is land consisting of continents and islands. The remaining 71% is covered with water, mostly by oceans but also lakes, rivers, and other fresh water, which altogether constitute the hydrosphere. The majority of Earth's polar regions are covered in ice, including the Antarctic ice sheet and the sea ice of the Arctic ice pack. Earth's interior remains active with a solid iron inner core, a liquid outer core that generates Earth's magnetic field, and a convecting mantle that drives plate tectonics. Within the first billion years of Earth's history, life appeared in the oceans and began to affect Earth's atmosphere and surface, leading to the proliferation of anaerobic and, later, aerobic organisms. Some geological evidence indicates that life may have arisen as early as 4.1 billion years ago. Since then, the combination of Earth's distance from the Sun, physical properties, and geological history have allowed life to evolve and thrive. In the history of life on Earth, biodiversity has gone through long periods of expansion, occasionally punctuated by mass extinctions. Over 99% of all species that ever lived on Earth are extinct. Estimates of the number of species on Earth today vary widely. Most species have not been described. Over 7.7 billion humans live on Earth and depend on its biosphere and natural resources for their survival. Geological history. Earth's atmosphere and oceans were formed by volcanic activity and outgassing. Water vapor from these sources condensed into the oceans, augmented by water and ice from asteroids, protoplanets, and comets. In this model, atmospheric greenhouse gases kept the oceans from freezing when the newly forming Sun had only 70% of its current luminosity. By 3.5 BYA, Earth's magnetic field was established, which helped prevent the atmosphere from being stripped away by the solar wind. A crust formed when the molten outer layer of Earth cooled to form a solid. The two models that explain landmass propose either a steady growth to the present-day forms or, more likely, a rapid growth early in Earth history followed by a long-term steady continental area. Continents formed by plate tectonics, a process ultimately driven by the continuous loss of heat from Earth's interior. Over the period of hundreds of millions of years, the supercontinents have assembled and broken apart. Roughly 750 million years ago, Maya, one of the earliest known supercontinents, Rodinia, began to break apart. The continents later recombined to form Pan-Oceania 605-40 Maya, then finally Pangaea, which also broke apart 180 Maya. The present pattern of ice ages began about 40 Maya, and then intensified during the Pleistocene about 3 Maya. High-latitude regions have since undergone repeated cycles of glaciation and thaw, repeating about every 40,000–100,000 years. The last continental glaciation ended 10,000 years ago. Physical characteristics. Shape. The shape of Earth is nearly spherical. There is a small flattening at the poles and bulging around the equator due to Earth's rotation. To second order, Earth is approximately an oblate spheroid, whose equatorial diameter is 43 kilometers, 27 miles, larger than the pole-to-pole diameter, although the variation is less than 1% of the average radius of the Earth. The point on the surface farthest from Earth's center of mass is the summit of the equatorial Chimborazo volcano in Ecuador, 6,384.4 kilometers or 3,967.1 miles. The average diameter of the reference spheroid is 12,742 kilometers, 7,918 miles. Local topography deviates from this idealized spheroid, although on a global scale these deviations are small compared to Earth's radius. The maximum deviation of only 0.17% is at the Mariana Trench, 10,911 meters or 35,797 feet below local sea level, whereas Mount Everest, 8,848 meters or 29,029 feet above local sea level, represents a deviation of 0.14%. In geodesy, the exact shape that Earth's oceans would adopt in the absence of land and perturbations such as tides and winds is called the geoid. More precisely, the geoid is the surface of gravitational equipotential at mean sea level. Chemical composition. Earth's mass is approximately 5.97 times 10^24 kg, 5,970 yg. It is composed mostly of iron, 32.1%, oxygen, 30.1%, silicon, 15.1%, magnesium, 13.9%, sulfur, 2.9%, nickel, 1.8%, calcium, 1.5%, and aluminum, 1.4%, with the remaining 1.2% consisting of trace amounts of other elements. Due to mass segregation, the core region is estimated to be primarily composed of iron, 88.8%, with smaller amounts of nickel, 5.8%, sulfur, 4.5%, and less than 1% trace elements. The most common rock constituents of the crust are nearly all oxides. Chlorine, sulfur, and fluorine are the important exceptions to this, and their total amount in any rock is usually much less than 1%. Over 99% of the crust is composed of 11 oxides, principally silica, alumina, iron oxides, lime, magnesia, potash, and soda. Internal structure. Earth's interior, like that of the other terrestrial planets, is divided into layers by their chemical or physical, rheological, properties. The outer layer is a chemically distinct silicate solid crust, which is underlain by a highly viscous solid mantle. The crust is separated from the mantle by the Mohiroa discontinuity. The thickness of the crust varies from about 6 kilometers, 3.7 miles, under the oceans to 30–50 km, 1931 mi, for the continents. The crust and the cold, rigid, top of the upper mantle are collectively known as the lithosphere, and it is of the lithosphere that the tectonic plates are composed. Beneath the lithosphere is the asthenosphere, a relatively low viscosity layer on which the lithosphere rides. Important changes in crystal structure within the mantle occur at 410 and 660 kilometers, 250 and 410 miles, below the surface, spanning a transition zone that separates the upper and lower mantle. Beneath the mantle, an extremely low viscosity liquid outer core lies above a solid inner core. Earth's inner core might rotate at a slightly higher angular velocity than the remainder of the planet, advancing by 0.10.5 degree per year. The radius of the inner core is about 1/5 of that of Earth. Surface. The total surface area of Earth is about 510 million km2, 197 million square mi. Of this, 70.8% or 361.13 million km2, 139.43 million sq.mi, is below sea level and covered by ocean water. Below the ocean's surface are much of the continental shelf, mountains, volcanoes, oceanic trenches, submarine canyons, oceanic plateaus, abyssal plains, and a globe-spanning mid-ocean ridge system. The remaining 29.2%, or 148.94 million km2, 57.51 million sq.mi, not covered by water, has terrain that varies greatly from place to place and consists of mountains, deserts, plains, plateaus, and other landforms. Tectonics and erosion, volcanic eruptions, flooding, weathering, glaciation, the growth of coral reefs, and meteorite impacts are among the processes that constantly reshape Earth's surface over geological time. The continental crust consists of lower density material such as the igneous rocks granite and andesite. Less common is basalt, a denser volcanic rock that is the primary constituent of the ocean floors. Sedimentary rock is formed from the accumulation of sediment that becomes buried and compacted together. Nearly 75% of the continental surfaces are covered by sedimentary rocks, although they form about 5% of the crust. The third form of rock material found on Earth is metamorphic rock, which is created from the transformation of pre-existing rock types through high pressures, high temperatures, or both. The most abundant silicate minerals on Earth's surface include quartz, feldspars, amphibole, mica, pyroxene, and olivine. Common carbonate minerals include calcite, found in limestone, and dolomite. The elevation of the land surface varies from the low point of 418 m, 1,371 foot, at the Dead Sea, to a maximum altitude of 8,848 m, 29,029 feet, at the top of Mount Everest. The mean height of land above sea level is about 797 m, 2,615 feet. The pedosphere is the outermost layer of Earth's continental surface and is composed of soil and subject to soil formation processes. The total arable land is 10.9% of the land surface, with 1.3% being permanent cropland. Close to 40% of Earth's land surface is used for agriculture, or an estimated 16.7 million km2, 6.4 million sq.mi, of cropland and 33.5 million km2, 12.9 million sq.mi, of pasture land. Gravitational field. The gravity of Earth is the acceleration that is imparted to objects due to the distribution of mass within Earth. Near Earth's surface, gravitational acceleration is approximately 9.8 m/s2, 32 feet/s2. Local differences in topography, geology, and deeper tectonic structure cause local and broad, regional differences in Earth's gravitational field, known as gravity anomalies. Magnetic field. The main part of Earth's magnetic field is generated in the core, the site of a dynamo process that converts the kinetic energy of thermally and compositionally driven convection into electrical and magnetic field energy. The field extends outwards from the core, through the mantle, and up to Earth's surface, where it is, approximately, a dipole. The poles of the dipole are located close to Earth's geographic poles. At the equator of the magnetic field, the magnetic field strength at the surface is 3.05 times 10⁵ T, with a magnetic dipole moment of 7.79 times 1022 am2 at epoch 2000, decreasing nearly 6% per century. The convection movements in the core are chaotic. The magnetic poles drift and periodically change alignment. This causes secular variation of the main field and field reversals at irregular intervals averaging a few times every million years. The most recent reversal occurred approximately 700,000 years ago. Rotation. Earth's rotation period relative to the Sun, its mean solar day, is 86,400 seconds of mean solar time, 86,400.0025 SI seconds. Because Earth's solar day is now slightly longer than it was during the 19th century due to tidal deceleration, each day varies between 0 and 2 SIMS longer. Earth's rotation period relative to the fixed stars, called its stellar day by the International Earth Rotation and Reference Systems Service, IERS, is 86,164.0989 seconds of mean solar time, UT1, or 23 hours 56 minutes 4.0989 s. Earth's rotation period relative to the precessing or moving mean March equinox, misnamed its sidereal day, is 86,164.0905 seconds of mean solar time, UT1, 23 hours 56 minutes 4.0905 s. Thus the sidereal day is shorter than the stellar day by about 8.4 milliseconds. The length of the mean solar day in SI seconds is available from the IERS for the periods 1623-2005 and 1962-2005. Apart from meteors within the atmosphere and low-orbiting satellites, the main apparent motion of celestial bodies in Earth's sky is to the west at a rate of 15°/H equals 15/min. For bodies near the celestial equator, this is equivalent to an apparent diameter of the Sun or the Moon every 2 minutes. From Earth's surface, the apparent sizes of the Sun and the Moon are approximately the same.